Go.
Okay, we'll start outside here with the solar panel. And as you can see, I've got it set up so that it's down here at ground level as opposed to on the roof. Our roof lines are not oriented correctly. They're old roofs, are going to have to be replaced someday, so we did not want the panel up on the roof. There's a couple of other reasons, but those are the key ones. Also down here, if necessary, I can fairly easily clean this off. The rain does a pretty good job. If you get rain, obviously it's been dry this summer, so it has not been that clean, but snow and so forth, much easier to get off. If you look at this, also I've got it up off the ground so that when we're mowing the lawn or snow blowing or whatever, a little less likely something's going to get thrown into it. And if you notice that this edge of the house going back, that is running true north and south, and the panel is skewed west of that. And the reason is we've got a lot of trees off to the east, not so many to the west, so the sunlight time is more to the west of straight south for this location, so that's why we did that. I've also got the panel at this time, we're in September, the date today is the 13th of September. We've got the panel tipped at about a 45-degree angle. We're at the 43rd latitude, so right now when the sun is prime, the rays are hitting the panel fairly square, getting the best reception of sunlight. Of course, when the sun gets to a point where it's setting, the angle is not so good, but this is the best time to have this angle. Probably along about the end of November, middle of November, somewhere in there. I'm going to try changing the angle, tip it up a little more because the sun will be lower in the sky in the wintertime. I want to try to stay with that 90-degree angle or as close to it as we can. We're not going to switch it every day, but 3 times a year. And then in the summer, we have the front lifted up, which in essence tips it back because the sun is up higher in the sky. Another thing that I did, this pipe is coming out of the top. This water has been through the panel, it's heated and it's going back to the house, and we'll show you that system in just a moment. The other pipe comes out and comes in the bottom corner, so that's had heat taken out of it and now it's picking up new heat. I have added to what the company sent, and you'll see it better in the basement. The plumbing for this is already pre-insulated and it's got a plastic wrap around it, and so it's a pipe about this big. But I've put that, at least on the outside here, inside a 4-inch corrugated drain pipe. I drilled holes in this periodically and injected expandable foam insulation to sort of fill this with more insulation. I can't see how good a job I did, so it's kind of a guesswork thing. But it's a little better insulated than the way it came from factory traffic. So I think that that's basically our situation out here. As I said, we're in September. I've got one nice big cloud up there right now, so we're not getting the direct sunlight. I guess I don't really need these. It's about 3:15. Our best time is right around 1 to 2 o'clock in the afternoon. This is still daylight savings time. But we'll take you inside and we'll show you where things go from inside.
Yeah, there you go.
Okay, now we're down in our basement. And the original propane hot water heater, it's got the insulation jacket on it over there. Up until we put this system in, we had water coming into this hot water heater from our well, and so it's coming into the house at approximately 55 degrees Fahrenheit most of the year. So it would be going into the propane tank and having to be heated up by propane from 55 to 120 or whatever it is that we have it set for. We don't actually have a temperature gauge on there, so I'm not sure exactly, but that's where we start from, is 55. Now you can see we've got these black pipes here. They're actually the plastic coating that I talked about outside. So this one here is the one that's coming in from the panel. It's been heated by the sun, comes into our control center, and I've got a a computer window here that tells me that the temperature out there right now is 122.1. There's actually a wire inside this insulated plastic coating here which goes to a thermometer out there, and so it knows what the temperature is out at the panel. 122. So that water comes in, comes through this computer system, goes into this storage tank which comes with a solar system. It then proceeds through a coil, probably copper tubing inside, and back out up to here. There is a pump here that is running. I know you can't hear it because I can't hear it over here. It's a very quiet pump. It's now pumping that water back out to the lower part of the panel that I showed you on the outside to pick up some more heat. So right now the temperature out at the panel, now it's up to 125.9 and rising. The sun probably came out from behind that cloud out there. I can also tell that down here at the bottom of the tank the temperature is about 113.3, and there's another sensor here that goes to the top of the tank that's 114.9. So now if my wife goes upstairs and runs the dishwasher, or hey, if I go up and wash the dishes for her and I turn on the hot water,
Yay!
the hot water is going to come out of the propane hot water tank, but to replace it, instead of the 55-degree water from the well, we now have 114.8 water going over there. Well, now if we are heating it to 120, the propane tank's only got to heat at about 5.5 degrees, and it's there. So that's where the savings comes. So far, well, and right now the pump is running at 30% capacity. It's not terribly hot out there. Certainly not a whole lot hotter than what's in here. So it's just moving the water along. If it goes through slower, it picks up heat better. But it could be higher if it was a hotter situation out there. Maybe if we had 2 panels instead of 1 or 3, by the time it comes out of there it would be hotter. For this month, the pump has been running for 58 hours. So we're at 13 days. So that's what? A little over 4 hours a day on average. Some days we've had some are 0. We've had some rainy, like last Saturday was a rainy, pewy day, 0. Some days like yesterday and the day before, 7. So it varies. Obviously it depends on the sun situation. Now this water that's in this loop and goes out to the panel, what about wintertime? If maybe it's just sitting out there and the sun's not shining, or overnight, is it going to freeze? No, it's got glycol in it and antifreeze, but this water stays within this closed system. This is a closed system loop. It does not mix with the water that's going up to wash dishes or clean our clothes or whatever. That water stays fresh. So that's our system. I come down here twice a day and record what the temperature is basically before the sun gets on it in the morning and after we've done showers and some whatever general cleanup we do in the morning and used hot water. That's quote unquote the coldest that this will be during the day. And then I come down again after sunset, or at least after the sun is off it and it's shut down for the day, when it's the hottest, and I record that, and then I put it into a spreadsheet, and you'll see those figures at another time in this program. And I've done that for a year now. We've had this running for a year, and so we can see what the average is for each month, what it is for the year, etc. So that's our system. Thank you.